Welcome to the Land of House YouTube channel. I'm Seth. This is the EFG 5 kilowatt hour lithium iron phosphate battery. This company sent this over so I can do a review so you can learn more about it. I'm going to be installing this in the crawl space under my house because it stays about 45 to 50 degrees under there most of the year. If you don't know, lithium iron phosphate batteries are not supposed to be charged below freezing. So included with this battery, there is a user manual. It has a couple of stickers. It has 4 different terminal screws, and it also has this wall mount bracket so you can attach this to the wall. Now the EFG company does have 3 different batteries at the time of this filming. It's got this one, which is the shorter but wider wall mount. They also have a taller but thinner wall mount and also a rack battery. So the plan for this video, we're going to take a look at the battery, open it up, check out the internals, and then we're also going to be mounting this to the wall, and then we'll do a charge and discharge test. And also the company asked that I connect their little cable that they sell separately to the computer, and we can actually get some data off of that as well. So if you're interested in learning more about this battery, then continue watching. Let's take a tour around this battery real quick. Up top we have the EFG logo, which stands for Energy Future Green. If we move down here, you've got the display, some buttons, and then some lights over here to show state of charge. You've got alarm and run. Here on the underside of the battery, there are 2 metal carrying handles, which are very nice to have. There are 2 black negative battery terminals down here. Over here there are 2 orange, and that allows you to connect to your inverter and also connect to a second or third or fourth battery if you need to. These do have covers on them if you want to not have any exposed cables. There is a power button right here. You've got your RS485 to allow you to connect to future batteries. There's an RS232, a CAN, and an RS485. These 2 are for connecting to the inverter. Here there are dip switches. You'll change these based upon the position of the battery. So for instance, if I have battery number 1, I would flip that switch right there up, and that would be the position for battery number 1. There's also a DC breaker over here, which allows you to turn this on and off. Moving over to the side, there is information about the battery right here, and a carrying handle up top right here. Moving over to this side, no more information, and it has this handle right here, and on the top is just blank. The back of the battery has these large metal plates with holes in them, and that's going to allow the mounting bracket here to slide in. Now I've done a test run and I've found that this actually has very low tolerance, and so it might make it a little difficult to hang. Find just the right spot before it slides in. Before I open the case to take a look at the insides, let's go ahead and turn on the power button here and then zoom into the menus. Let's press the menu key here. There's a down button here that lets you collect different things. 52.76 volts, 6.1 C for the temperature. I want to open up this battery real quick and take a look inside. So while I'm doing that, let's go ahead and read off some of the specifications here in the user manual. This is the model number EFG W48100. The nominal voltage is 51.2 volts, capacity 100 amp hours, energy 5.12 kilowatt hours. The dimensions of this battery are 21.6 inch by 16.5 inch by 6.1 inch. Weighs 106 pounds. The design life is for 20 years, 4,000 cycles, CB at 80%. It has an operating temperature of -4 degrees to 140 degrees Celsius. The operating voltage is 51.2 volts DC. The max charging voltage is 57.6 volts. Cutoff discharge voltage is 43.2. And the max charge and discharge current is 100 amps. Let's go ahead and lift up the lid of this battery and see what the inside looks like. Now I anticipate the screen to be attached here, so good. It does have a nice long cable so you can move that screen to the side. Now up under this plate is where the actual batteries are. Just taking a quick look inside here. to see what things look like. So there's a 6-gauge wire going to the terminals. It has a metal plate here to connect between the two. Same goes for the negative side over there. Now the actual cells are underneath this metal plate. I don't really think I want to remove that, but if we zoom in here, hopefully we can see down in there the bars that connect each of these cells. I took time without you to get the wall plate mounted in the crawl space under my house. So now it's time to get this battery hung up on the wall. It weighs 106 pounds, and so I need to be very careful moving this by myself. I think what I'm gonna have to do is slide it down through my crawl space on a board and then use some buckets and maybe even my car jack to get this up into position by myself, because I'm going to be squatted down in the crawl space of the house. So let's go ahead and step under the house and see how well we can get this battery installed before we start doing our charge and discharge tests. This is the entrance to my crawl space where the battery needs to go. Now remember, this thing is 106 pounds, so don't want to get hurt moving this thing. My goal is to use the back plate here to slide this down these 2x4s so that I don't have to actually do any heavy lifting into this small space. So let's go ahead and see how well this is going to work. All right, so far I think it's a good plan. I just slid the board all the way over here to the wall, where you can see I've got the mounting bracket up here, and it is ready for this to go onto. So all I did was put a couple of scrap boards behind it, and I pre-drilled into my concrete wall with a masonry bit, and then I used some Tapcons to place that in the wall. I've got 4 screws, and that should be more than enough to hold 106 pounds. Now, I was considering how to get this thing up on the wall, and first I thought maybe I will use the car jack, but then I think it would be too unsteady, and so my next thought was, why don't I use a bunch of scrap blocks here and kind of just step this thing up into position. And I've also got some buckets, as you can see, back under here. So that should allow me to hopefully control this up onto the mount here. Now once I get it up there, I need to be very careful to slide it and drop it down without damaging anything. So, all right, that's the plan. Let's see how it does. There we go. All right, well, we're halfway there. Not the most stable thing, but let's see what I can do next. Okay, I think I'm close enough. It's high enough. I'm gonna try to bear hug this thing and get it up a little higher. We'll see how that goes. Well, got it up on the knee. Alright, well, now that I have it up on a knee, maybe I can coax these blocks a little higher. Okay, well, we're now within like a couple inches there. Blocks, don't fail me now. Okay. Boy, let's take a moment to step back here and consider life for a moment. Well, that was a bit unpleasant, but the battery is now hanging where I wanted it. So I did just check, and the cable length is going to be sufficient to attach to these terminals as we had anticipated. So that is great. Okay, let's continue with the review. I'm going to hook these up, and then we will go out and program the charge controller because it's a nice sunny day today. We'll get this thing fully charged. Got the red cable over here. It's going to go on the orange or positive terminal. Get that into position. Then I can take the black and move it over here to this side. Now I don't have any power coming in, and so this should not have any kind of spark whatsoever. I also brought these little covers to put across here. While I'm down here under the crawl space, let's go ahead and turn on the battery. These two cables come up from the battery. I've turned on the breaker. This first set of panels is the solar we're working with right now. It's about 1:30 in the afternoon, and so the peak sun is pretty much upon us. Now that I have the EFG battery mounted in the crawl space of my house to stay warm, I have connected it out here to my outdoor power shed. I've got a 6,000 watt off-grid inverter and also a couple of charge controllers connected to 3,000 watts of solar. So what I want to do now is hook up a battery meter and do a discharge test that I will time using this big inverter. And once we've done that, we'll flip the solar back on and do a charging test to see how well this thing is doing. So with 3,000 watts of solar, I should be able to get this thing charged up decently quick today on a nice, pretty day. All right, so let's go ahead and hook up a battery meter and also begin discharging with this big inverter. I just crawled up under the house to show you the state of charge here on the battery. So as you can see, the run lamp is showing full, and also the state of charge has all 4 of the LEDs on. So this battery is fully charged and ready for our discharge test. I have connected a battery meter and set it up to have 100 amp hours. The battery is showing 53.7 volts currently. And so my first test is going to be simply hooking up a load to this off-grid inverter and watching this display to see how long it takes for this to get down to basically 0 amp hours. And we will then do a recharge test. Now after all of this, I will be using the app that comes with this battery, and so you can hook up the data cable and get some better results. But I just want to do this test with this meter to do something simple first. So let's go ahead and put a load on this inverter. Okay, the inverter is now ready for a load. Let's go inside where I have this load connected, and we will turn on a heater and then come back out here to watch the battery in operation. I have this heater connected to this outlet, which is connected to that inverter. I've also got my stopwatch ready. So let's go ahead and turn this on to setting number 2 and begin this stopwatch. So that is a heater. All right, and so we are running 1.1 kilowatts on that little heater, 22 amps. We've got 52 volts on the battery. The watt hours have dropped down to 99, and we have used 53 watt hours or 61 watt hours currently. So let's keep an eye on this and see how it's doing. Whenever this gets down to 0 or close to 0, I will stop this, and then we will see how the time looks. Test is now 2 hours and 39 minutes in. We've got 41.6 amp hours left here. Still running consistent at 22 amps and 1.1 kilowatt. Battery is at 51.3, so still doing well on the battery. We've got 3 kilowatt hours used so far. All right, let's continue to use this test until we get down to just slightly above 0. Now at 3 hours and 43 minutes, we've got 17.9%, 1.1 K still, 22 amp, and we've got 4.2 kilowatt hours used. The battery is at 50.5 volts. Now of course that 50.5 is under load, so whenever that load is removed, it will jump back up the voltage a little bit. All right, well at 4.2 kilowatt hours, we are still doing quite well on this battery. It's now been 4 hours and 9 minutes. We're down to 8.3 kilowatts left here on the battery. Voltage has dropped down to 49.9, and we've got 4.7 kilowatt hours. So we are almost done here. Looks like probably another 10 or 15 minutes, and we'll call this test. 4 hours and 29 minutes. I'm going to call it 4 hours and 30 minutes because we've got 0.7 amp hours left, 49 volts, and it's got 5 kilowatt hours. So this battery has performed fantastic here on this test. Very pleased. Just turned off that heater and now turning off the inverter. Let's see what we have now for the voltage. It is jumped up to 50.8, so a little bit low there, but definitely, well, 50.9. It may jump up over a little bit of time here. Now for the fun of it, I'm gonna go ahead and turn on the solar. It's pretty much totally dark out here, but we'll get a little bit in there. 137 watts, 50.8. And now it's jumped back up to 51.1. So yeah, 51.2 is the normal empty voltage there. So very cool, nice test. I let the EFG battery charge back up in the sun, and then I connected it to my grid tie limiter inverters, and those have been running for a couple days now at about 700 watts whenever there is a load in my house. So let me show you that real quick. All right, if you look down here, I've got about 1600 watts coming into the battery. And if I move over here, I don't know if you can see that or not, I've got 723 watts there. And this one's got 736 watts. I'm not sure you'll be able to see that. So yes, that battery is putting out a lot of power and also accepting a lot here from the sun. Let's go ahead and move under the house now, because EFG sells this data cable that lets you connect the battery up to a computer through a USB. So we can get some data on this while my dryer is running here in the house. I'm back here in the crawl space under the house where it's time to check out this data cable. Now over here we've got the RS485 port, which we had looked at previously. And so this cable is actually sold by EFG, and it has the basically phone cable on one side right here, and on the other side has a USB. So we'll be using this to connect to the battery and communicate through a laptop here. So let's go ahead and first of all plug up this data cable here. There we go. And on the other end will be to the laptop. Okay, it's taken me a while to get set up here, and I just realized my dryer has turned off, so we may not see tons of output here, but we can at least get this started. Okay, I've got my laptop. When this boots up, I'm going to plug up my USB, and I should get some drivers loaded on here real quick. I will have a link in the description down below where you can get this Pbms tools software. This will allow me to basically monitor this battery. Now it has to have the .NET framework before it will work. But whenever it loads up here, you'll notice that it's in Chinese. And so if you click the little flag down here, you can then select English and then click the blue button, and it's going to change out all of the text here on the screen so that it is now English. Okay, the battery is connected. I'm going to go ahead and push the try connect here and see if it's going to load up. I removed and reset the USB cable and then restarted the program, hit connect, and everything worked just fine that time. So let's go ahead and show the information that's available here. So we are on the real-time monitoring. Now my dryer turned off, and so there's no longer any power going in or out of the unit. We've got 53.947 volts is the pack voltage. There's no current currently. The state of charge is 100%. Now the full capacity is 103 amp hours, and you can see we are basically at that right now. It has been cycled 4 times, so I've had this in the house for 3 nights, and then our initial test with the discharge, and so that's correct with the 4. Now down here you have the cell voltage. So it has cells 1 through 16, and you can see the voltages there in millivolt. So number 12 is the max at 3,413 millivolt, and number 5 has the least, and there's a voltage difference of 65 millivolts, so not much there. Up here on the top you've got temperatures, all 4 different cells, and then you've got, for instance, the environmental or the case here at these temperatures. We can also go over to the parameter settings tab, and I've already clicked the read all, but you can go through here and see the different settings that are here on this battery. You can go in here and change some of these values, but I'm going to let them be from the manufacturer settings. So basically you can use this program to monitor and adjust some things on this battery. It is pretty handy because you can't get to all of these things just based on the screen of the battery. So check out the link in the description down below and run this program so you can check out the internals of your battery. Working with the EFG wall mount battery has actually been quite pleasant, except for having to hoist up 106 pounds onto the wall. The discharge tests show that it is spot on at 5 kilowatts, so that is really good to see. Now I have cycled this now for 4 different times and it has performed quite well. I checked my power consumption from the grid and noticed that it was significantly lower my full day of use yesterday, which I will show you that here on my little power chart. So if you want to check out the EFG battery, I will have a link to their website down below. I've been in contact with their customer support about 4 different times and they have been very responsive, so that is definitely good to hear. Also, like I just mentioned, you can get this data cable and that will connect straight to your computer. Hopefully you have yours in a better position than I do up under the crawl space, but that will let you monitor things that you can't see on the display. And as you saw outside, I have one of those little battery meters that's also really nice to be able to see what's going in or going out of the battery and also keep track of the total power that has been back and forth as well. Definitely check out the link in the description down below to the EFG website so you can get some more information on this battery. I'm Seth with Land A House and I will see you in the next video. Bye.